Engines. The Avro RJ is powered by 4 Allied Signal LF507-1F twin-spool high bypass ratio turbofan engines. Each of the engine's thrust is generated by a geared fan driven by the low-pressure spool. AC electrical generators are fitted to engines 1 and 4, hydraulic pumps fitted to engines 2 and 3. Fuel flow to each engine is controlled by a full authority digital engine control, FADEC, with mechanical reversion. An autothrottle system allows full thrust modulation by the flight guidance system. Each engine is protected against ice by the use of engine bleed air and internal hot oil spray. An overheat detection system provides fire warnings, and 2 fire extinguishers on each engine may be used to stop the spread of fire. The engine is comprised of the following 4 modules: a fan module, a gas producer module, a combustion turbine module, and an accessory gearbox module. The air passing through the fan is divided by a splitter. Most of the air is accelerated through the bypass duct, generating most of the engine's thrust. The remaining air is compressed by a 2-stage low-pressure compressor called a supercharger and delivered to the gas producer module. Here, air is further compressed to high pressure by a 7-stage axial compressor and a single-stage radial compressor before being delivered to the combustor turbine module. Fuel is delivered into the combustion chamber by multiple fuel nozzles. The fuel-air mixture is ignited and exits via a 2-stage high-pressure turbine, which drives the high-pressure compressor stages. Before exiting to atmosphere via the jet pipe, the hot gases are passed through a 2-stage low-pressure turbine, which drives the 2-stage supercharger and a fan via a reduction gearbox. Each engine is fitted with an accessory gearbox which is driven by the high-pressure shaft. The systems driven from the accessory gearbox differ depending on the position of the engine. Each accessory gearbox drives a fuel boost pump, a hydromechanical unit, HMU, and an oil pump. In addition, it drives a hydraulic pump on the inboard engines or an AC generator on the outboard engines. For engine start, a starter motor is fitted to each accessory gearbox. A drain mast is fitted to the bottom of each engine cowling and contains sealed drain lines for the system shown here. Bleed air is extracted from 3 different points on the engine for air conditioning and ice protection. The upper bleed port is used for air conditioning, airframe ice protection, and other air supplies. The other bleed ports are used for engine ice protection. Engine anti-ice. The fan spinner is continuously anti-iced by an internal oil spray. The air intake lip and the airflow splitter are separately anti-iced by hot bleed air taken from the final stages of compression. Hot air can be bled via 2 engine anti-ice valves on each engine, controlled by a single switch on the ice protection panel. The valves are pneumatically actuated and electrically powered shut. Selection of engine anti-ice illuminates engine anti-ice on the central status panel. When the airflow splitter anti-ice valve is open, engine valve not shut illuminates on the ice protection panel. This indicates that hot air is being delivered to the splitter. Operation of the air intake lip anti-ice valve is indicated by 2 annunciators on the ice protection panel. Intake low pressure indicates low pressure beyond the intake anti-ice valve and should extinguish when the engine is operating above flight idle. Intake high pressure indicates that the intake anti-ice valve has failed to regulate the bleed air pressure correctly. Either caution is accompanied by ice protection on the central warning panel. To prevent engine surge, the engine anti-ice valves are automatically opened during engine start. To prevent high EGT after start or cutout, engine anti-ice is selected on before start. Bleed band. In order to allow correct response of the engine during starting and periods of acceleration or deceleration, air is bled from the high-pressure compressor by opening and closing of a bleed band assembly, controlled from the FADEC. Fuel system. Fuel is delivered by the AC boost pump in the wing feed tank via a low-pressure shutoff valve, which is controlled by the fire handle to the engine-driven low-pressure fuel pump. It then passes through a fuel heater to a low-pressure filter. Should the filter become blocked, filter clogged will appear on the central warning panel. Fuel then passes through the hydromechanical unit, HMU, which contains a high-pressure pump, a high-pressure shutoff valve, and a metering valve which under normal operations is controlled by FADEC. The high-pressure shutoff valve allows the engine to be stopped and is directly controlled by the thrust lever. From the hydromechanical unit, fuel is fed to the fuel nozzles in the combustion chamber. Ignition. During engine start, ignition is provided by either ignition system A, B, or both. Ignition is automatically terminated when combustion becomes self-sustaining. The ignition system is not normally used after engine starting, but continuous ignition A or B must be selected on when operating from contaminated runways and when flying through areas of severe turbulence or heavy precipitation. Engine ignition is also used during in-flight engine start. This is covered in the engine starting module. Oil system. The oil system is completely self-contained and includes an oil tank, oil pump, oil fuel heat exchanger, and an oil filter for each engine. Oil is replenished at the oil tank, which contains a dipstick and a transmitter for the oil contents gauge on a flight deck triple gauge. The oil pump, which is located on the accessory gearbox, also contains the oil filter. Low oil pressure is indicated by oil low pressure on the central warning panel. Each engine is divided into two zones for fire detection purposes. The area between the fan casing and the cowling is termed Zone 1. The area between the engine core and the core casing is termed Zone 2. Each zone is equipped with two fire loops, designated Loop A and Loop B. Each pair of loops is connected together in parallel to form two independent detection systems. Either pair of loops may be selected as the active detection system on the engine fire detect panel. Failure of a loop will illuminate loop fault for the appropriate engine on the central warning panel. When an overheat condition is detected by the selected loop, the warnings shown here are given. The fire bell and the red alert flashers may be canceled by pressing either of the red alert flashers. All the other warnings will cancel once the temperature at the sensor falls below a preset limit. The fire warning system for each engine may be tested by the use of 4 engine fire test buttons on the ground test panel. Pressing an engine fire test